Namaste everyone. Welcome you all to Sadvidya Academy Physics classes by Ganesh Shabbar. Today's topic is Class 11 Physics Chapter number 1 Units and Measurements Part 4 Calculation of Errors. In this particular section, we shall discuss about how to measure the error or how to find out the magnitude of errors in the measurement of any physical quantity. There are three methods of measuring the errors. First one is about the absolute error. Second one is about the relative error. Third one is about the percentage error. We should discuss these one by one. First one is about the absolute error. What is the definition of absolute error? What is mean by absolute error? It is the difference between the true value and the individual measured value is called as absolute error. We shall see what is this. We have to know about the words true value and the individually measured values. Let us suppose I am measuring any physical quantity A. Then for in different trials I will get the readings A1, A2, A3, A4, etc. So these are all some of the readings which I obtain in different trials. Then in order to find the actual value, what I do in your laboratories and all. So while performing the experiment, you take same values many times. Then you take a single value at the end. How you take that single value? That you take the arithmetic mean of the all individually obtained values. That value itself is called as the true value, or it is also called as the mean value. Mean value or true value, both are one and the same. That is written as AM. True value is always written as AM, A mean, which is equal to, how to find that? It is to find that is nothing but the mean or the arithmetic mean or the average. So that is A1 plus A2 plus A3 plus like that. How many values are there? That much AN divided by the number of values, that is n. When we take the ratio of the sum of all the individual values divided by the total number of values, I will end up getting the mean value of that physical quantity. That itself is called as the true value. That itself is called as the true value of any physical quantity. Now, by knowing about the true value, now what is individually measured value? All these A1, A2, A3, etc. ANs are called as the individually measured values. So then by knowing about individually measured values and the true value, we shall see what is an absolute error. What is an absolute error? So the difference between the true value and the individually measured values. That means absolute errors, there are how many values will be there, that much of absolute errors will be there. How to represent absolute error? Absolute error is represented by using a delta sign here, delta A, like that we represent. So there are how many values? N number of values, that much number of absolute values will be there. So which are the absolute value? What is the absolute error? Absolute error in the measurement of first value, that is delta A1, is equal to, it is the difference between what? It is the difference between the true value, that is AM. Difference means the subtraction. AM, what is it to subtract from mean value? The individually measured value. That is the delta A1 is the absolute error in the measurement of the first value. Like that, what is the absolute error in the measurement of the second value? That is AM minus A2. Like that, if you go on finding out, what you will get? Delta AN, that is absolute error in the measurement of nth value, is equal to AM, that is A mean true value, minus the individually measured value, that is AN. These are all these delta A1, delta A2, etc. Delta A3. All these are called as delta A2, delta A3. All are called as the absolute errors. Absolute errors ಅಂತ ಕರಿತೀವಿ. So delta A1, delta A2, delta A3 ಇವುಗಳನ್ನೆಲ್ಲ ನಾವು absolute errors ಅಂತ ಕರಿತೀವಿ. Next, what is the next type of error is nothing but the mean absolute error. So just I will erase this value. What is mean absolute error? So what is mean absolute error? Mean absolute error, the definition of mean absolute error is the arithmetic mean of the absolute errors. What is absolute errors? We have already find out which are all that. So delta A1, delta A2, like that, delta A3, it's all these values like that. Delta AN, you have to add all of them, then you have to take the mean of that absolute errors. So that is called as, so how many number of values are there? N number of values. So when I take delta A1 plus delta A2 plus delta A3, etc. delta N divided by N, what I will get? I will get the mean value of all these deltas, delta A's. So I will write it as delta A mean. So it is represented as delta A mean. That is nothing but the mean absolute error. It is nothing but the mean of the absolute errors. That itself is called as the mean absolute error. Then one more kind of measuring the error is, that is the relative error and percentage error. First we shall see what is relative error. What is the definition of relative error? It is the ratio of the mean absolute error to the true value. So what is mean absolute error? Mean absolute error, that is nothing but delta AM. Delta A means that is sum of all delta S, delta A1 plus delta A2 plus delta A3, like that delta AN divided by N. That itself is called as delta AM. So it is a ratio of this, that is mean absolute error, to the true value. How to represent the true value? That is nothing but A mean. Is it not? So this ratio is called as the relative error. That is called as the relative error, that we call it as a relative. That means we are relating that error with the true value, relating the mean absolute errors with the true value. That is called as relative error, is given by relative error is equal to, so I will write properly, relative error. So relative error is equal to the delta AM. Delta AM is the mean absolute error divided by AM. Divided by means ratio. Divided by AM means AM is the mean value or the true value anta karitivi. So AM is nothing but the true value, or delta AM is nothing but the mean absolute error. So its ratio we call it as a relative error. And what is the next error? That is a percentage error. So what is percentage error? So relative error which is measured in percentage. Relative error which is measured in percentage, that itself is called as percentage error. That means percentage error. Percentage error. How to write percentage? I can write it in words or as well as in symbolic form. That is percentage error is equal to, which one is represented in percentage? The relative error. Relative error is above. Which one? Delta AM divided by AM. When this itself is measured in percentage, that is 100%, multiply by 100%, whatever the answer we get, that is called as the percentage error in the measurement of that particular physical quantity. So what we have discussed, there are three types of measurement of error. First one is absolute error, second one is about the relative error, and third one is about the percentage error. Next we shall discuss about the combination of errors. What is the meaning of combination of errors? So every measurement what we do will have some error. But say for example there is some formula. We won't find out all the values directly. Some values we calculate, some values we obtain and then substitute in some formula and then we get some other result. In such cases, what happens to the error of that particular sum or that difference or that product, that we are going to study in this particular concept. That is nothing but the combination of errors. What happens to the errors if you add any two physical quantities, or if you subtract any two physical quantities, or if you divide one quantity by the other, or if you multiply one quantity and the other, what happens to the actual error, that we are going to study. We shall study these one by one. First one is about error of a sum or difference. Let us assume that you have a formula. That is, let us assume you have a formula. A physical quantity Z is equal to A plus B. There are two physical quantities that you are measuring directly. That is, A and B are measured directly. Now, but you cannot find out Z directly. At that time, what you do? But you know that the relation between Z, A and B, you know already. That is, A plus B, when you do, you should get Z. In such case, what happens to the error in the measurement of Z? We already know A will have certain amount of error that is written as delta A. It is nothing but the absolute error in the measurement of A, that is delta A. Like that, B will also have some error, that is delta B. It is nothing but the absolute error in the measurement of B. In every measurement there will be some error. So A also has some error, B also has some error. So but you have the formula Z is equal to A plus B. At that time when you add A plus B, what happens to the measurement of the error of Z? That is the question. That is, there will be some error, of course. Sure, A will have some error, B also will have some error. That is why Z will have some error for 100%. But we don't know how much is that error. So that error in the measurement of Z is given by, that is, absolute error even if you add. So I will remove only the plus sign. Even if you add two quantities or if you subtract the two physical quantities, the error in the measurement of Z will always be the sum of the error in the measurement of A. That is actually the absolute error in the measurement of A plus the absolute error in the measurement of B. That means even whether you add two physical quantities or you subtract any two physical quantities, the error always gets added up. That is the thing which you have studied in this particular concept. That is the error. There is no subtraction in the error. Error will not decrease even if you subtract any physical quantities. When you subtract any two physical quantities, always the error gets added up only. Always errors are additive in nature. Errors are additive even if you additive in nature, even if we add to physical quantities, add to quantities, if we add any two quantities. But remember, errors are always additive. That is, delta Z is always equal to delta A plus B. It may be Z equal to A plus B or A minus B, whatever the case. In both the cases, the error gets added up only. Next, second type is what happens to the error of a product or a quotient. Similarly, in the same example which I have given in the last example, error of a sum, same example I will take. Let us assume that there is a quantity Z which cannot be measured directly. It is actually the product of A and B, A into B. Or let us assume There is one more, that is the same quantity z, which is obtained by the division of b by a, that is a by b, whatever be the case. For both the values I am getting the same answer, that is why I have taken both together. Even if you multiply any two physical quantities or if you add any two physical quantities, error, what happens? Let us see that error will be same in both the cases. Let us, here we are not concerning about the absolute error. Let us assume that I have already told you while measuring A and while measuring B, there will be some error. So here I will take delta A be the absolute error in the measurement of A divided by A. When I do, what I will get? It is a relative error in the measurement of, relative error in measurement of measuring A. Right, that is delta A by A. Similarly, B will also have some error. So it is nothing but delta B. It is the absolute error in the measurement of B. If you subtract the true value B from it, what you will get? It is nothing but the relative error in the measurement of, relative error in measuring what? Measuring which one? The quantity B. Now, what happens to the error in the measurement of Z? Whether the if there is, say for example, in the second case there is A by B, whether the error may vanish? No, not possible. Error will not get vanished. You may say that it is A by B, so error in the measurement of A divided by error in the measurement of B, they both cancel each other. No, it is not possible. Always, if I take delta Z, always remember there will be some error in the measurement of Z also. Why? Because A and B has some error. That is why delta Z be there, absolute error in the measurement of Z, divided by actual value of Z, that is a true value. So what I obtain is, it is a relative error in the measurement of, relative error in measuring what? The value Z, that is measuring the value Z. So what will be the formula? That is delta Z by Z, even if it is multiplication or division, delta Z by Z is always equal to the sum of the relative errors in the measurement of all the physical quantities. Always delta A by A plus delta B by B. That means relative error in the measurement of any quantity Z is equal to the relative error in the measurement of A plus relative error in the measurement of B when any two quantities A and B are multiplied or divided. Even if they are divided or even if they are multiplied, the error will always get added up. Remember, there is a plus sign here, that is delta A by A plus delta B by B. That is nothing but the sum of the relative errors of the individually measured physical quantities. That is nothing but error of a product or a quotient. In both the cases it is the same. It will be sum of the errors, individually measured relative errors in the two physical quantities. The next one is combination of error is the error in the case of a measured quantity which is raised to some power. What happens? Say for example, there is one more formula same as above, that is Z is equal to A to the power n. There is some formula like that. So here we are not measuring Z directly. We are measuring A and taking the power of A to the power n. Then I am obtaining the value of Z. Now what happens to the error in the measurement of Z then? So it is nothing but, actually we can derive this by using the previous one. A to the power n is nothing but A into A into A into A into how many times? N times. At that time what happens to the error? Delta A by A. I have already studied. Multiplication A into B equal to delta A by A plus delta b by b, but here there is no b and a, here everything is a only. So again delta a by a plus like that delta a by a, how many times? N times. So what happens? Delta a by a plus delta a by a, like that n times. If you do, what you will get? N times delta a by a. That is actually z is equal to a to the power n. That is the measurement of the error in the measurement of z, that is equal to n times the power times the relative error in the measurement of a. Actually this is obtained from like this: a into a to the power n is nothing but a into a into a into a, how many times? N times. So what is the measurement of, we are going to find out the error in the measurement of z, that is relative error in the measurement of z, that is delta a by a is nothing but relative error in the measurement of, relative error in measuring what? Measuring the physical quantity a. Like that, what is delta z by z? It is nothing but relative error in the measurement of z. So how to obtain it? So delta z by z is a to the power n is nothing but a into a into a into n times. Now what is delta z by z? From product, the previous one what we have discussed. So when it is z equal to a into b, what happens to the error? Error delta a by a plus delta b by b. But here a and b are not different. Here everything is a only, a into a only. So what happens to the error? Delta a by a plus delta a by a, like that, how many times? N times. How can you write this? N into delta a by a. So that means what? How can you write this? If the measurement of a quantity is a to the power n, then the relative error in the measurement of z is equal to n times, that is nothing but the power times the relative error in the measurement of a. That is actually the formula for this particular, the error in the case of a measured quantity raised to some power. That completes the concept of the measurement of the combination of errors. Thank you.